Dear friends, hello. Today we'll continue our discussion on data manipulation language, that is DML. In the last lecture, we have discussed about the insert statement of DML. Now we will continue our discussion with the update statement of the DML. There is need to update or modify the data already stored into the tables of the database. We store the data into the tables using the insert statement of DML. So, in order to modify or update the existing data, we use the update statement. So, update statement is used to modify the column values of a table. Update statement is used with set clause to overwrite the previous value in the column and adding a new value for the column field. It also uses the where clause. This where clause is used for updating selected rows satisfying the condition mentioned in the where clause. So, look at the syntax of the update statement as shown: update table name, set column name equal to value, column name equal to value, where condition. So, in this syntax, the update keyword is used to specify that we want to update row or rows of a table of name table name. Set keyword is used to overwrite the previous value of the field with new value. Column name specifies the name of the column whose value is to be updated, and the value is used to give new value for the column specified in the column name parameter. There can be only one column or more than one column whose value is to be updated. So, we can update as many columns as we want, but all should satisfy same condition, and this condition is specified in the where clause. In where clause, we give the condition for finding the rows whose values is to be updated. Look at this example for using the update statement as shown: update employee set last underscore name equal to Smith, where employee underscore ID equal to E101. In this example, in the table employee, the last name of that employee will set to Smith, where EID means employee ID is E101. Update statement can also be used to update multiple rows at the same time. For example, update employee set salary equal to salary multiply 1.05, where age is greater than 50. In this example, all those rows of the employee table will be updated where the age of the employee is greater than 50, and it will increase the salaries of all the employees whose age is greater than 50 by 1.05 times. Now, after inserting the rows in the table, we may need to delete them. In order to do so, we use the delete statement. So, delete statement is used to delete one row, more than one row, or all the rows from the table. It is used for deleting only rows of the table, not the columns. So, in case we delete all the rows of the table still exists in the database with same name and same columns, but only the data stored in that table is deleted. The syntax of using delete statement is as shown: delete from table name where condition. In the syntax, the delete keyword specifies the action of the deletion from the table whose name is given in table underscore name parameter. and in the square brackets we have specified where clause with a condition, and which is optional. Optional means to say that if we will not use where clause, then all the rows of the table will be deleted, whereas if we use the where clause, then only that row or those rows satisfying the condition mentioned in the where clause will be deleted. An example of using the delete statement is as shown: delete from customer underscore details. So, this statement will delete all the rows of the table customer underscore details, because we have not specified the where clause. Now, look at another example in which we have specified the where clause as shown: delete from customer underscore details where cust underscore id equal to 101. Here in this example, as we have specified where clause, so only those rows with cust id equal to 101 will be deleted. This statement may lead to deletion of either one row or more than one rows, depending upon how many rows in the table satisfy the condition of cust underscore id equal to 101. Besides inserting, updating and deleting the rows of a table, we also require retrieving the rows from the table, and this retrieval is done by the select statement. Select statement is used to retrieve the rows and columns of table, or even the whole table can be retrieved. The syntax of select statement is as shown: select attribute list from table list where search condition, order by, sort specification, group by, grouping column having search condition. So, in this syntax, the keyword select is used for specifying the retrieval, or we can say fetching action. The attribute list parameter is for specifying the names of the columns of table which we want to retrieve. We can retrieve some columns of the table or all the columns of the table. If all the columns are to be retrieved, we will mention asterisk for this parameter. Look at the example: select asterisk from employee. Here we have mentioned asterisk for mentioning that we are selecting all the columns of the table employee. This statement will retrieve all the rows and columns from the table employee. That is, this statement will retrieve the whole table. Now, look at this example: select EID salary from employee. Here we have mentioned attribute IDs, that is employee ID and salary, specifying that we are selecting only these two columns of the table employee. So, this statement will retrieve only two columns named EID and salary, but will all their rows from the table employee. So, the keyword from is used to specify from where we want to retrieve data, and table list parameter is used to specify the table name from which data will be retrieved. We can retrieve data either from only one table or more than one table at the same time. Thus, if there are more than one table names in the table list parameter, the multiple table names will be mentioned with comma separation. Look at the example: select EID salary from employee. Here, after the from keyword, the table name mentioned is employee. Thus, in this particular query, we are retrieving the data from only one table employee. Look at another query. Select employee dot employee ID, department dot department ID from employee comma department. In this query, the data is fetched from two tables, employee and department. The column employee ID or EID belongs to the table employee and DEPT underscore ID belongs to department table. That is why qualifiers has been mentioned along with each attribute. By qualifying, we mean specifying the name of the table along with the attribute, so that while execution of the query, correct column be picked from correct table. This is also mandatory sometimes, because there are cases when we are fetching the data from multiple tables and those tables has same column names. We try to fetch that column that is present in multiple tables with the same name. Then how the system will know which column to pick and from which table? So, we must qualify the column name by mentioning the table name along with column name to avoid confusion and error. Look at this example. Select employee dot E underscore ID, department dot E underscore ID from employee comma department. So, in this example, both the tables employee and department has the column with the same name E underscore ID. Now, we want to fetch this column from both the tables. So, we will qualify the column name E underscore ID with the respective table names, as it is clear from the above example. Secondly, we can give the alias, that is dummy name, to be displayed in the resultant relation of this query. So, look at this example. Select employee dot E underscore ID, EMP underscore E underscore ID, comma department dot E underscore ID and DEPT underscore EMP underscore ID from employee comma department. So, the resultant table will have the columns with headings EMP underscore E underscore ID and DEPT underscore EMP underscore ID, specifying the data fetched from the tables employee and department. In case we do not mention these aliases, then the heading of the columns in the resultant table will be employee dot E underscore ID and department dot EMP underscore ID only. Please note that aliases only make the presentation of the results in a good manner, and this makes the results more readable and understandable. The clauses where, group by, having and order by are all optional, and the use of these clauses depend upon what type of query we want to write and what we want to fetch. The where clause is used to specify the search condition. If we use where clause, only those rows will be fetched which satisfies the condition given in where clause. Look at this example. Select asterisk from employee where salary greater than 20,000. Here in this query, the condition salary greater than 20,000 has been mentioned after the where clause. Thus, only those rows will be selected from this table, employee whose salary is greater than 20,000. This statement will return the data of those employees from the employee table whose salaries are greater than 20,000. And moreover, we have not mentioned any column name or column names. So, this statement will retrieve all the columns of the employee table. The order by clause, it is used for sorting purposes. It sorts the result returned by the select statement in the ascending or descending order. By default, it sorts the result in ascending order, and if you want to sort the results in descending order, then keyword DESC is used along with that column name in order by clause, according to which we want to sort our result. Look at this example. Select last name, first name, salary from employee where department ID equal to 3, order by salary descending. So, in this query, the result of the query will be displayed after sorting in the descending order on the salary attribute, because order by salary descending has been mentioned. Now, this statement will retrieve columns last name, first name and salary with all their rows from employee table where department ID of the employees equals to 2. Result will be a sorted list. The result will sort according to the salary column in the descending order as specified in the statement. The group by clause, it is used in select statement to collect data across multiple records and group the results by one or more columns. Sometimes it is required to get the information about each group rather than about each row. For this, we use group by clause. Also, when we use group by clause, we need to specify only those columns in the group by clause that have been specified in the select statement. Related rows can be grouped together by the group by clause by specifying a column as a grouping column. In the resultant table, all the rows with an identical value in the grouping column are grouped together. Hence, the number of rows in the output is equal to the number of distinct values of the grouping column. For example, look at this query. Select department ID, count employee ID from employee, group by department ID. So, this statement will count number of employees in each department, as in this statement grouping column is department ID. So, it will make groups of each department based on their IDs and will count the number of employees in each department. It is to be noticed here that the column which we have specified in the column list of select statement, same column is used in group by clause. So, as many columns we specify in the column list of select statement, as many columns will be used in the group by clause. The having clause, it is used along with the group by clause. The having clause can be used to select and reject row groups. The format of the having clause is similar to the where clause, consisting of the keyword having followed by a search condition. The having clause thus specifies a search condition for groups. Look at this example. Select department, count employee ID from employee, group by department having count of employee ID greater than 2. So, this statement will retrieve one column named department from employee table and will make another column of the counting of greater than 2 of employees in each department. Here count function will count total number of employee IDs. The having clause will reduce the grouping rows. So, next we move to the third sublanguage of SQL named data control language, or we say DCL in short. So, DCL is the sublanguage that is used to control the data, as its name reveals. DCL statements are used to control access to the database and the data in it. This controlling is done by the database administrator, as he or she is the one who is responsible for the data. DBA does it so by controlling the access of different users to the database and its contents. Thus, we can say that DCL is used to enforce data security. To control access to the database and the data, DCL consists of 4 statements. The first one is grant statement. The grant statement is used by the database administrator to grant security privileges to specific users on database objects. The tables stored in the database usually store very sensitive and important data of the table owner. So, it should be protected and it should not be given access to every user. So, in order to protect them, the grant statement is used by the owner to give other users access to the data. The privileges that an owner can give to the users are select, insert, delete and update. The syntax of using the grant statement for granting the privileges is as shown: grant, select, insert, update, delete or all privileges on table name, to username or public with grant option. So, here grant keyword is used to instruct that we want to grant something to someone. The privileges that can be granted are select, insert, update, delete or all of these. These select, insert, update and delete are the DML statements that the granted user can use on the data, and the table name parameter is used to specify the name of the table on which privileges are granted. The privileges can be granted to one or more users, or it can be available for all, as this can be specified by the username or public parameters respectively. The user who has the privileges can grant them further also, but only by the permission of DBA, and the DBA give this permission using the optional field with grant option. So, example of using the grant statement is as shown: grant select insert on customer details to admin. In this example, we are granting privileges of select and insert to user admin on the table customer underscore details. By these privileges, the user admin will be able to retrieve and insert data in customer underscore details table. Next example is grant all privileges on customer underscore loan to Jack. Now, in this example, we are granting all the 4 privileges to the user Jack on the table customer underscore loan, and by these privileges the user Jack will be able to retrieve the data, update, delete and insert the data in the table customer underscore loan. Next example is grant all on customer underscore loan to public. So, here all the privileges has been granted to all the users on customer underscore loan table. By these privileges, all the users will be able to retrieve, update, delete and insert data in customer underscore lawn table. So, the granted privileges can also be reverted back. For this, revoke statement is used. The revoke statement is used to revoke the privileges back from the users. This means that taking back the granted privileges from the users, and its syntax is revoke, select, insert, update, delete or all privileges on table name from username or public. This syntax is same as that of the syntax of grant. The major difference between the keywords revoke and from are revoke is used to specify that we want to revoke some or all privileges, whereas from is used to specify from where we want to revoke privileges back. So, some of the examples of revoking privileges as shown: revoke, select, insert on customer underscore details from admin. So, in this example we are revoking the privileges of select and insert from the user admin on the table customer underscore details. By this, the user admin will not be able to insert the data or retrieve the data from the table customer underscore details. Next example is revoke all privileges on customer underscore loan from Jack. Now, in this example we are revoking all the privileges from Jack from the customer underscore loan table. By these privileges, the user Jack was able to retrieve, update, delete or insert the data in the customer underscore loan table, and now it has been taken back. Next example is revoke all on customer underscore loan from public. So, in this example we are revoking all the privileges from all the users on the table customer underscore loan. Besides these two statements, we have a statement commit. Commit statement is used to save changes permanently into the database. When a user uses any DML command to modify the data, some changes in the data are made. These changes need to be saved so that next time user uses the database, he can use it with changes. Therefore, after using any DML command, commit command is executed. The syntax of commit command consists of only one keyword, that is commit. This statement is standalone and hence cannot be used along with any other statement. Sometimes we want to undo the changes we made in our data, and these changes can be undone by the use of rollback statement. Rollback happens sometimes when we mistakenly delete any row of a table or modify the value of any cell, and in that case we would like to undo the changes. For this purpose, SQL provides us with the DCL command rollback. By using this command, we can undo any changes made by use of DML commands in the database. Like commit, it is also used standalone and used for transaction purpose, and the syntax for the rollback command is rollback. This command rollbacks the changes from the database. With this, we come to an end of today's lecture. Today we have discussed some of the commands of DML and the commands related to DCL. Thank you.